CCI, Crash Course Instrumentation, presents episode number 65, KVL in the Real World, EKGs, smelters, and shock paths. Cold open. The same loop rule that balances a breadboard also keeps people safe in a smelter and makes medical monitors work. Today we walk 3 real-world loops and let KVL tell the truth. Viewer promise. By the end, you will use one loop story to understand EKG measurements, aluminum smelter, movable grounds, and everyday appliance faults. You will know how to pick a reference, walk a loop, and decide risk. Quick bridge from episode 64. Ground is just our chosen zero. Change the reference and the numbers move, but the differences in the circuit do not. Keep that in mind as we enter the field. Section 1. Why EKG leads work. Human skin and gel pads create tiny junction voltages. Each electrode sees a slightly different push or pull. When the monitor compares leads, the opposed junction effects largely cancel and the heart signal appears. That is a clean difference measurement. Field tip. If the trace is noisy, check prep, lead placement, and the single-point reference lead. A poor contact changes the loop you are measuring. Safety cue. Lead wires are designed to keep patient current extremely low. Never improvise probes on a person. Use approved cables and follow hospital policy. Historical note. Early 20th century EKGs used giant string galvanometers and salt bath electrodes. The measurement was still a loop story. Careful contacts, a defined reference, and a differential reading. Section 2. Aluminum smelter movable ground. Hundreds of low-voltage cells sit in series along a pot line. Add them end to end and the total difference can reach around 1,000 volts. To keep reading simple and work safer, operators tie one chosen pot to earth. That point becomes 0 for instruments and procedures. Move the ground to another pot and all ground reference numbers shift. Yet the cell-to-cell differences stay the same. KVL still balances the loop. Field tip. When a meter reading looks impossible, ask, where is the plant ground today? Verify the ground switch position and the drawing notes before you probe. Safety cue. Treat the whole line as energized. Use rated tools, one-hand probing, and a spotter. Your reference choice improves understanding, not immunity. Section 3. Everyday appliance fault and shock path. A failed appliance can place its case at an unexpected potential. Do not guess. Walk the loop. That includes hot, neutral, the case, and earth. Define your ground. Trace a single closed path through the suspected fault to your shoes on the floor. Mark the rises and the drops in words. If your loop includes a low impedance path through your body, the risk is high, even when a single meter reading looks small. The loop decides the hazard. Field tip. Test the cord ground pin, confirm bond jumpers, and use a receptacle tester before touching metal cases. If GFCI trips, find the leakage path before restoring power. Section 4. Mini Lab. 1 loop, 3 stories. Set up 3 safe demos, an EKG simulator with snap leads, a low-voltage cell string on the bench, and a line-powered tool plugged through an isolation box. For each demo, pick one reference, then take single-ended readings. Switch to differential readings between key points. Listen for the same words every time. Rise, drop, difference, ground. The story stays consistent, even when the numbers change with the reference. Section 5. Common mistakes in the field. Mistake. Assuming chassis equals earth without checking. Mistake. Changing ground mid-troubleshoot and comparing numbers from different references. Mistake. Probing open loops and expecting KVL to balance. Close the path you are evaluating. Mistake. Confusing noise pickup with real signal, shorten leads, twist pairs, and use differential when appropriate. Section 6. Field checklist. You can use today. Choose and mark your reference. Trace exactly one closed path. Call source pushes, rises. Call load uses drops. Use differential when ground referenced numbers are confusing. Decide risk by the loop that includes you, not by one node reading. Tiny historical note. From hospital wards with salt bath electrodes to heavy industry with movable grounds, technicians learned the same lesson again and again. Pick one reference, walk one loop, and let the differences tell the story. Call to action. If this series helped you see circuits more clearly, please like, subscribe, and share it with a classmate or a coworker. Credits, on-screen and spoken. Thank you to Tony Coupalt and the open source community for the model materials that make Crash Course Instrumentation possible.